Oh, and now we're being recorded.
I just turned it on.
Okay, great. Welcome, folks. We're just going to wait one more minute until we actually hit half past the hour. We're going to try and start on Trip Barber time. And just a heads up before we get going, I'm going to go into full screen mode so that you can see the slides at the highest quality. And Bruce will be monitoring the chat. We don't have a Q&A capability for today, but Bruce will keep an eye on the chat session because that's going to be blocked for me. And Bruce, can you see the full screen, the full
Yes.
slides now?
Mm-hmm.
Lovely. Okay, thank you. Okay, welcome to the first virtual NARCON, build it, fly it, make it, take it, whatever you want to call it. I'm Will Marchant. Thanks for coming today. And Bruce, can I get you to introduce yourself, please?
Hi, I'm Bruce Canino, and I'll be the man behind the scenes, monitoring the chat room. And when we break out, if you have individual questions about doing this on a Windows machine or a Chromebook, you'll be coming to me. So, and everything else will control the show.
Yeah, and you'll probably remember Bruce from last year, last vNARCON, where he did a really great talk about flying Arduinos and hobby rocketry. And so we chatted. There'd been some articles in Sport Rocketry about flying Arduinos. Those had been of the sort of more normal Arduino format. This is the Uno. This is actually the SparkFun Inventors Kit, which comes with a proto board so that you can do little electronic experiments and stuff. And so I'm Will Marchant.
I don't have.
Turn off your camera.
Anne's not on today. I will ask everybody to please mute your microphones if you don't have a question to ask. So what we're going to do today is I'll do a slide on Zoom logistics, a brief description of what the project is and what it isn't. There's some terminology associated with the computer world. I'm going to go over that. And then resources for future learning, because we are hoping that this will be a project that you'll want to continue to develop. And then I'll go through a brief overview of the various components for this particular project. And then we'll spend a fair amount of time actually going over how you load software into this Arduino, because frankly, I think that that's probably the most difficult portion of this, is my guess. And we'll talk a little bit about flight testing and then expansion possibilities. And hopefully, if I can avoid yapping too much, we'll have a lot of time at the end of the session for questions and also to try and help people get their computer up and running. So you probably noticed that the presentation is being recorded. I heard John Hockheimer say that you will have exclusive access for the next 90 days. And then after that, this recording is going to go up onto the NAR YouTube page for other people to enjoy. You know, the usual Zoom thing of please mute your microphone unless you're actually intentionally speaking so that we can avoid some background noise. Turns out we don't have a Q&A window for this, but there is a chat window, and Bruce is going to be monitoring that. I'm in full screen mode to try and give you the best resolution for the slides, so I can't really see what's going on. But Bruce is going to maintain situational awareness, and will help you through your chat stuff. And then There is a reactions button at the bottom of your screen, and you can click on that, and then there's a raise hand bar, and that'll pop up a little raised hand thing. And so if you really want to ask a question, go ahead and do that. But I encourage you to try and use the chat. Just with the number of people we have, it's going to get a little bit difficult to coordinate vocal stuff. Sorry about that. So what the project is, last year, Bruce's Arduino talk, the articles in Sport Rocketry magazine, lots of interest in Arduino, but it sort of seemed like people were having a tough time deciding how to get started because there are literally thousands of microcontrollers out there and lots of software systems and things like that. So the idea with this project was to give you basically a cookbook recipe for how to put something together and get it to fly. And this is really just the basic project. So it's no solder, so you can just plug cables together. You don't have to do any wiring or things like that. The basic capability is just to show you what the maximum altitude that your rocket reached at the end of the flight. There's tremendous expansion capabilities. We'll talk about some of those things later. So this project you'll be able to take it basically just about as far as you want to take it to do all sorts of other things. What it doesn't have currently is there's no deployment capability. Now, you could add that. You could add relays, or you could add, FETs, transistor switches, or whatever. There would probably be some soldering involved in that. And frankly, I'm a little bit uncomfortable with this level of hobby project as your sole recovery system deployment. If you want to go down that road, I think it'd be wonderful, but I would encourage you to fly a reputable commercial altimeter as a backup for your deployment systems. The other thing was, we wanted a project that was small enough that you could fly it in small fields and that wouldn't break the bank, so you could fly it a lot. I know C and D size motors aren't as cheap as they used to be, but they're still pretty cheap when compared to H and above. So we picked this Estes Green Eggs rocket, which John Langford mentioned last night in his keynote address that he's flying the Pocket Labs in this thing. Who else went out and bought a Pocket Lab because they look so cool? But the Green Eggs rocket with the BT65 payload bay is just a really convenient size. It'll fly 24 millimeter motors. The C11, I got a flight to about 300 feet with this exact configuration and payload. D12 is giving me 700 feet. That's lovely for flying in just about any field. Now, I did want to point out over here, excuse me, these three boards are basically the project boards. Up here, this is a Flight Sketch Mini standalone altimeter that I've been flying to cross-check the results of the Arduino. So that is not technically a part of the project, but I'd encourage you to fly some sort of other altimeter to cross-check your results. Flight Sketch has got some really nice stuff. There's a Jolly Logic altimeter series, Altus Metrum. If you go to the NAR competition page, you'll see that there are a handful or two handfuls of altimeters that are now certified for competition and record use. And so that's a great resource to help you pick a commercial altimeter to go along with this. So the computer terminology. Adafruit.com, that's an electronics company, and I really like them because of their tutorials. We'll talk about that a little bit later. I've been saying Arduino a lot, and that's just really, it's an open source electronics platform. I mentioned earlier, this is this red board over here is an Arduino Uno. That's the sort of traditional sized platform. And somebody was flying these and wrote up an article in Sport Rocketry last year that was really interesting. To give you a size comparison, this is the feather format board that we're specifying for the project today. Now you notice on this Arduino that there are a number of connectors along the side. There are things called shields that will plug into those, and they'll give you expansion capability to do other things like run relays or motors or servos or whatever. That feather format that I just showed you also has an equivalent to a shield, and it's called a feather wing. Basically the same idea, gives you expansion capabilities, servo controls, motor controls, GPS receivers, all sorts of other things. Now in the Arduino ecosystem, they call programs a sketch. And so when you hear anybody saying sketch in Arduino, it basically just means a computer program. Now, one of the cool things about the Make It Take It program that we're doing today is it's no solder. And we wanted to try and make it a little bit more approachable for people who maybe don't have a lot of electronics building skills. So you can see that on this processor board, there's a nice little connector with a 4-pin cable that you can daisy chain to the sensor. This is the barometric temperature and humidity sensor here, and then that daisy chains up so it connects and goes on through to the display chip up here. This particular interface, you don't particularly have to know this one. I just thought I'd say it so you were familiar with it. Is called a Stemma QT, and it's a long story to explain the name and stuff, so I won't bother. That's basically what Adafruit calls their boards that use this daisy chain capability. There's another cool company called SparkFun. They make lots of really good boards, and they have a line of daisy chainable things called Quick, and it uses the same connector. Quick peripherals are supported by Stemma QT, but there are some Stemma QT peripherals that you can't plug into a microprocessor that has, that just does quick support. So you need to be a tiny bit careful there. These 4 wires all use what's called the I2C bus. It's just a serial bus that's used commonly in the industry, mostly for communications between chips on a printed circuit board, but it's been expanded into the hobby community to support integrating different sensor packages like this. So resources. Today's slides are available on Excel events, and of course the video is going to be available for 90 days just to you folks. vNAR has started using a system called groups.io, groups.io. And you can see that there's a groups.nar.org. This is mostly for individual sections so that they can have an email list to be able to exchange email with their members. But it also has a capability for this really cool user interaction ecosystem. And I think that we're, with this Make It Take It program, the first one to actually try and use the rest of these capabilities. So if you go to groups.nar.org, I don't know why the G is in there, and then Make It Take It. And this link is up in Excel events so that you can find it. And if you go down there, it'll take you to the top of this Make It Take It, and there's a message board here where if you want to get support after today, or you just want to say, hey, I've done something cool, then feel free to post here in the messages. If you want to post, you may have to join, but that's free to NAR members. And then there's some photos of various things like the payload bay and some data examples. There's files, the Arduino sketches, so the programs that you need. There's a rock sim for the green eggs rocket, so that you can do some simulations to make sure that your rocket will fly safely and predict the performance. Copy these slides. But the thing I want to point out was this wiki. So we were telling people to, buy these parts a month ago. Hopefully people were able to get parts. I saw that Adafruit was kind of out of stock on stuff, and I'm apologizing for that. But you've been hearing this entire weekend about how the part shortages and shipping shortages have been impacting all the industries. At work, we're getting quoted, 50, 52-week delivery times on parts that we need for flight programs. So it's really pretty desperate. But anyway, if you go down, and there's some additional stuff here that Bruce and I and some of the early adopters are putting in. But if you go to this first chapter on the Make It, Take It, there's basically, hopefully, step-by-step instructions on what things to buy, what other stuff you need, and how to put the project together. So I'll go back here. So that's this link here, and I already mentioned the sketches and the rock sim. If you go down to the references section there's a link to the Estes page about the green eggs. There's links to the boards that we're having you use. And then there's a link to the Adafruit tutorials and the main Arduino.cc. That's the company that really is sort of, the intellectual property holder for the Arduino ecosystem. And so they have lots of really good resources there. So I'm going to go back to full screen and the next slide.
Well,
go ahead, Bruce.
A couple people pointed out they can't, even though I can see your cursor, they're having a hard time seeing it. Maybe you can make it bigger or something. I don't know if that's an option.
That is an excellent question, and I don't know how to do that in Google Slides.
Is there a laser? Oh, so this is Google Slides.
This is Google Slides.
Yeah.
So if somebody wants to take a couple minutes and go off and take a look at Google Slides and see if you can figure out how to, let me see if I can view. I don't want to burn up too much of your precious time right now trying to figure out how to do this.
Okay.
But and there's a suggestion I could change it on the Mac. Maybe I've never done that, so I don't really know how to do it. Maybe when we're I have a few slides I'm going to go through, and then we're going to take a break to give people a chance to try doing the blink sketch. And while people are doing that, I'll mess around and see if I can adjust the cursor side. Meanwhile, I will try and verbally describe what I'm doing. So a basic overview. On the left-hand side here, you'll see a sticker that says green eggs. These are basically the parts that come with the green eggs kit. So you can see it's a pretty basic 3 fins and a nose cone sort of rocket. Pretty easy to put together. You can put one of these things together in an hour or so. And notice that the payload bay comes, it's one molded piece. You need to slice that open so that you then have an aft section to the payload bay and the nose cone forward section that goes on to the actual translucent payload bay there. This sled in the middle picture, you can see this plywood sled that I've cut out. that has a couple of little tangs at the top and the bottom. Those fit down inside the openings in the nose cone and that aft adapter. And then the wider section is what is visible inside the translucent payload bay. Um, there's a nice lithium polymer battery which plugs into a connector. The larger circuit board on the right-hand side of that sled, that's the computer processor itself. In the lower left-hand corner, there's a plastic connector. That's the battery connector. The battery plugs directly into that. At the very bottom, you can see perhaps there's a metal connector. That's a USB-C connector. That will supply data, power to the board, and the board has its own built-in charger, lithium polymer charger. So when USB-C is plugged in and supplying power to this board, if the battery's plugged in, the battery will be charged up. And there's a little yellow light over on the right-hand bottom corner of the processor that will go out once the battery is completely charged. The computer board in the middle, that's the BME 280 sensor board. So this is the thing that measures temperature, pressure, and humidity. It's actually that little tiny chip in the middle. The rest of this stuff is all interface stuff, so that the I2C bus, this Stemma QT bus that has a connector in the center of the Arduino Feather board, can get plugged into one of these connectors. You can see the cables loose at the top. And then a second cable can plug into the other side of that BME 280 sensor board, and then can plug into the OLED display. The display card only has one single input, so you can't daisy chain past this. It has to be the last thing in the row. And so you'll want to pay a little bit of attention to that when you lay out components on the board. So you can see I labeled the board which end is pointing up. It's always nice to know where the pointy end is that should be pointing at the sky. And then I put a label on here for the OLED. That's the display. The BME 280, that's right here. When you're tracing the holes of the BME 280 onto the plywood sled, put it on the sled in this orientation, and that'll put the circuit board right up against the plywood. It means you can put a pencil in those 4 holes and you can mark where you want to drill. But then when you mount this thing, mount it upside down so that the sensor is in between its printed circuit board and the sensor is actually facing the plywood. Just about all of these altimeter sensors these days are now sensitive to extraneous sunlight. And so you want to try and keep sunlight out of these things. If you mount this board upside down, then you're practically guaranteed that you won't be able to contaminate the data with by getting sunlight on it. And then these are approximate dimensions for the sled. There's a photo of this in the photo section over at the groups.io. So the green eggs kit comes green eggs with this yellow and green sort of translucent payload bay. I have trouble reading the displays through this green. So if you get one of the Estes Olympus kits, which are only available from Hobby Lobby, it comes with the exact same size parts, but they're a little bit easier color, at least on my eyes. Now, one of the things you'll see here is that you need to be able to get in and out of this payload bay to plug and unplug the battery and do stuff like that. You could use tape to hold these things together. I use some of these removable plastic rivets, and I punched a hole. And then, I can practically never get my holes exactly 180 degrees apart from each other and exactly the same distance from the end of the tube. So what I tend to do is I mark the transparent payload bay, and I put a little bit of mark on there so I know which hole in the aft adapter lines up to which hole in the payload bay. And then it's not quite as difficult for the nose cone, but I put an A there so that I know that this hole over here goes onto this side of the payload bay. Whatever works for you. If you want to use tape, that's a lovely thing. And I will point out that the molding process for these nose cones leaves a hole back here. You can see that I used a little bit of aluminized mylar tape to close that off because you don't want the ejection charge pressure from the recovery bay in, the aft end of your rocket. You don't want that ejection charge blowing up into the rocket and getting, debris onto the altimeter and also contaminating your readings. So this is kind of what it looks like all put together. You can see on this side in the middle, there are 3 strips of 1/4-inch masking tape holding the battery. On the reverse size photo, there's just 1 piece of masking tape there. This is good enough for for flying those C and D sized motors. If you want to put this thing in a high power rocket, you should do a better job of mounting the battery. And Additive Aerospace, there's a link to this in the wiki, makes some nice 3D printed battery holders for lots of different size batteries. This is the battery that we recommended for the project today. And so you can see that this holder holds that nicely, and then there's room for a couple of bolts. Yeah, go ahead, Bruce.
When you're in full slide mode and you're holding up something, you need to get out of because they can't see you.
Okay, is that better?
Actually, well, let's see. He's saying, "Oh, go to present." Go to present.
So should I stop sharing for a minute to show that? Or?
Oh yeah, maybe that's what it is.
Okay, let me just see if I can stop sharing.
Oh, okay. Now they can see you. Okay.
Okay. So this is the Additive Aerospace battery holder, and this is the Adafruit battery that we were recommending. And so you can see that that goes in there pretty nicely, and then you could mount it on the aft side of your avionics sled with a couple of bolts. Okay, sorry about that. Let's go back to slide mode. Bruce, you seeing the full slide now?
Yes.
Okay, great. So I think that's what I wanted to say over here. Now the next slide, I was going to talk through the process of loading the Arduino code onto the Mac. And frankly, this seems like it's sort of in the early adopters who were coming and posting on the groups.io forum. It seemed like getting this to work was the most difficult thing. You basically need to install the Arduino IDE. That's the integrated development environment, and add a board definition. And there are instructions for this over in the avionics setup and testing section of the wiki. And I've got a recording that I'll show how to do that process. And Bruce, if there are too many people shouting that this is boring over on the chat, just let me know and I'll shut up and move on to something else. But basically, once you get the Arduino IDE installed, there's a thing called the Blink Sketch, and that's pretty much the simplest thing that you always want to try anytime you get a new board in. It's just a little tiny Arduino program that you can load up, and then all these Arduino boards have a little light on them, a light emitting diode. And this sketch, all it does is it'll turn that LED on for a second, then turn it off for a second. If you can do that, and then if you can go into that sketch and you can change it so that the light is on for a half a second and then off for half a second, for example, and upload it again, and you see the frequency of that light changing, that tells you that you're in control of the situation and you're able to compile and upload sketches. So once you add that blink sketch, I'll go through this stuff on the desktop so you can see what it looks like. You plug in your Arduino. Hopefully your computer recognizes it, and you can select the communications port for the Arduino. You upload the blink sketch, and then you celebrate and do a little happy dance when you see the red light blinking at the frequency that's of interest. So I'm going to start this video. There's no audio to it, and so I'm going to try and narrate what's going on. And it starts off at the top of the groups.io page for this Make It Take It. So here we're running, and you're going to be seeing the cursor that got recorded is right there, and I'm apologizing again that it's small. So the idea is you go to the wiki on the Make It Take It page, and then you go up to the top to chapter number 1, which is the getting started thing. And then you frantically scroll down to the avionics setup and testing thing. Oh, and you scroll too far, so scroll back. And one of the things you want to do is you want to go to the Adafruit learning guide, which has steps about how to get started. You really do want to read through all this stuff before you go to the Arduino IDE setup section, where you're downloading the integrated development environment. This example is on a Mac, and so I'm clicking on the Mac OS X example. You don't have to give Arduino folks money if you don't want to. And so this is installing the IDE on a Mac, and so there's this archive utility thing that gets the code and downloads it and expands it from the website. On the Mac, you take the executable and you put it over in the applications folder. On the Mac, that's where everything lives. We'll do a breakout room with Bruce where he can talk with you about Windows stuff and Chrome stuff. Now, the next step is the IDE needs to know about this exact board that you're using. And so there's in the preferences menu, and so I'm going over into the applications folder to launch the Arduino IDE here on the Mac. And so and the Mac has a security thing where you have to say, yeah, it's okay to load software. But then what you want to do, so you want to get into the Arduino IDE, but then you have to tell it about this ESP32S2 Feather board that you've bought. So you open up the preferences, and over on the Adafruit page, there's going to be a URL. It'll be an HTTPS URL to a place called GitHub. And you can see that it's in that sort of pinkish color there on the left. So all you want to do is cut and paste a copy of that into that board's description area in the preferences. So just copy and then paste it in there, and then do an OK to get out of the preferences. And then you really want to, at this point, quit out of the Arduino and get back in again. In order, so that because the Arduino IDE, when it wakes up, is when it really processes all that stuff in the preferences. So you're going to see me fumbling around because I forgot to do that while I was recording this, and I'll eventually figure that out, and I'll quit. You can watch on my mouse work here as I get back into the Arduino IDE. And then you'll see that under the tasks bar and under the boards, there's a boards manager thing. And you typically only need to do that once, because in between runs of the Arduino stuff, it'll remember what board you have. So click on that boards manager thing. Oh, sorry, I'm forgetting a step. So you need to select these ESP32 style boards that they then show up in the boards manager. So there's that search menu at the top. You do ESP32, and then you just click install. And that actually installs the board manager. And so you wait for this to process. It's moderately fast on a desktop or a laptop machine. If you do this on a Raspberry Pi, it takes a little while, and you want to go off and have your lunch break or something and then come back. And normally I would try and skip ahead a little bit, but I'm afraid of skipping past something and then getting confused. So and then what you want to do is look under the ESP32 Arduino stuff and under the boards manager and pick the Adafruit ESP32-S2 one for the board. That's there are a couple of ESP32 options. You want to make sure you just get that ESP32-S2 and it'll say Adafruit on the front of it. Okay. So now the Arduino IDE is set up, and so you want to come back to the file section of the make it take it area and go down into the sketches area and look for the Adafruit ESP32 blink. And when you click on that, your computer should download that and say that it wants to load it into, it wants to open it up with the Arduino IDE. So, and Bruce notes, you probably don't need to do any of this bootloader stuff. When we were getting boards fresh from Adafruit, it seemed like you didn't have to do any of this bootloader stuff. They just showed up as, and I should be selecting the port, and then you should see a port down there that says Adafruit ESP 32S2. You want to select that, and then that right arrow button, that's the thing that will compile the sketch. And you shouldn't see any error messages down under that compiling sketch thing. Hopefully it just ends up with those 2 lines of text. And then you'll see some red stuff that shows that it's actually loading the software over to the Arduino. And then it'll say leaving or something. If there aren't any error messages over there, you should have an Arduino now that's gotten loaded up. And I'm going to stop sharing for a moment. And I'll show you what, so this is the feather, and I've programmed it. And we'll see if, I don't know if you can see the little blinky light that's right down next to the connector. So that's, after all that struggle and strife and hair pulling, that's the big revelatory moment, that if you see that that LED blinking off and on once per second, then you should declare victory and you've loaded your first sketch onto an Arduino. So let me go back into screen sharing. Hopefully you're seeing slides again.
Yes.
Okay. So what we thought we'd do at this point, and we can take a poll. Well, let's take a 15-minute break. I'm going to start up a breakout room, and Bruce is going to go into that breakout room because he's really the Windows Chromebook expert. And so if you have questions about getting your Arduino IDE running, or if you want to try getting that running in real time, Bruce will be over there to help you out with that. I'll stay up in the main room. I can help with Linux, Mac, and Raspberry Pi stuff. Let's meet back here in 15 minutes. So let's call that 25 minutes past the hour, and we'll see how everybody's doing.
I did have somebody did come up with a question, and apparently they're running on the Mac, and they're getting an error, and I've seen it a lot in pretty much just says can't find module serial, and the fix for that is you have to go into terminal mode and say pip install power serial, and that'll get you going. The other thing is, if I don't know if it's a problem on the Mac, I've seen it in Windows. If you get all through it and you get to the part where it tries to load and you get an error accessing the serial port, you got to add, was it dial out to your run group. So those are two errors. It's probably not on the Mac, but in playing Linux versions, unless you're part of the group that owns the USB ports, you can't access it.
Interesting. Okay.
I have the commands how to do it. I just I need to post them.
Okay. All right. Good hints, Bruce. Maybe we can get those up in the. We've got a. There's an appendix to the wiki that talks about how to do the IDE on various operating systems, and then Bruce made up a hints about how to deal with problems. And so I'm not sure which place those hints should go in, Bruce, but maybe if you could take an action item to add those there.
Yeah,
and then
okay.
Let me just say that Google is your friend for all this stuff. There's one of the nice things about Arduino is that there's a huge user community, and people are usually pretty welcoming about helping you out. And so, try Googling for error messages. And as I said, we've enabled that messaging forum up on the groups.io thing, and so feel free to come there and say I'm seeing this error. Please, can somebody offer some suggestions?
When I switch, somebody brought up the point that they hope that both rooms are recorded. I'm recording the one that I'm in. I don't know if I switch over, when I switch over, if it'll get yours. You may have to hit record on your side to pick up the main room.
Yeah. I don't know. Let's You know, or if you just want to stay here, Bruce, because I don't, are we getting a lot of questions from people about how to get their stuff going, or are we just ready to move on to the next
Hi, I tried to, waiting, I'll prove somebody. I haven't got any questions about, I guess maybe, if you can raise your hand, if you're actually installing it now, I can see what's going on with that and see if we need to do that. Cliff, you said, are you still pending? Because I don't see you as pending.
Oh, so yeah, so Cliff, you might, that's interesting. You might have to join the main group, the main NAR group before you can get into the groups.io stuff. Yeah.
I approved one other person. If you, I got another. Oh, okay. I'll if you're joining, I'll approve you as you come in.
And I think you should be able to see all the content without joining. I don't think you'll be able to post messages and stuff until you actually join that group, but you should be able to look at everything.
You don't. I don't think you get access to the files either.
Okay, and I see Lynn Thomas has a hand up. You can go ahead and unmute if you wanted to say something.
No, you does. I'm working to install the Blink software. I've done it before on my laptop, but not on this machine. You'd
Okay,
ask for
great.
you'd ask for hands up if we were doing that. That was all.
Excellent. Okay, thanks. Thanks for the heads up and hands up about that.
I approve Robin.
Okay, well, you know, maybe we don't need the breakout room.
Okay.
So I'll just go ahead and close it.
Oh,
And
Bernard has a question. Go ahead, Bernard.
Well, not a question. When Will was talking about covering the bottom hole in the payload section of the green eggs, I actually had a couple of slides in my altimeter presentation yesterday that shows exactly how crappy the data is you get if you don't do that, which I'd be happy to share whenever anybody wants to see it.
And Bernard, if you want to send, if those are on the web and you send those to me, then I'll add them to the over in the wiki. We've got a subsidiary section talking about altimeter bay venting, and I put a link to your article in the Apogee Peak of Flight newsletter. But if you've got those particular graphs online or something, I'd be happy to link to those. I think that'd be an interesting thing.
I can pull those 3 pages out of my presentation from yesterday and put them in a PDF or something and send them to you probably.
Yeah, that'd be awesome. If you're comfortable with getting that published up on the website, then
Well, the pitch
I'll,
is up on the Excel events website now, I think, underneath my talk. So, but it's the whole
Okay.
deck, not just those 3 pages.
okay.
But it's pretty ugly.
Yeah, I saw
Cool.
that. I watched your presentation. That was a, every once in a while you see that and it's really spiky. So like, what's causing that? That's probably a pretty good reason.
Yeah, so I should look at in more detail because I just used some aluminized Mylar tape over that, and it didn't occur to me at the time that that might actually function as sort of a drum head or something for transmitting some of that pressure.
I
Um,
don't think that you've got an issue with that, as long as you've got some static holes in the payload section as well. I actually had a little bit about something kind of like that in a different part of the pitch, but I just have a piece of that Scotch clear multitask tape, which is my favorite go-to clear tape for all kinds of things across the hole in my model right here, as you can possibly see. If I get it close enough to the computer, you can see the light reflecting off of it.
okay,
So
great.
yeah, I'm sure your Mylar tape is fine.
Okay, the 2 people who were waiting for approval should be approved.
How did it seem to go, guys?
I think we're probably almost ready to move on. Post in the chat if you need some more time, or if you have any questions, or raise your hand. Otherwise, I'll plan to move on to the next phase. Jeff asked where the sketch files are located. If you go to the groups, and I'll go ahead and share the screen again. So hopefully you can see my screen. If you go to the groups.nar.org, and then and if you actually go to groups.nar.org, what you'll see is this NAR link that takes you down to where all the different sections have their email stuff set up and things. But if you click on this make it take it, that's where you want to go, because that's where the cool kids hang out, right? And then if you click over here in the files section, and then if you look in Arduino sketches, Bruce has made up a zip file that's got all of these things in it. But basically what you have here is this Adafruit ESP32 blink. That's the version of the sketch that'll just blink that one LED. And then the display only make it take it. That's basically what that does is the display just runs, and once a second displays the temperature, pressure, humidity, and the battery voltage and state of charge. So that might be useful if you're going to try and put this and some altimeter into a test chamber. So you could see the exactly what the feather is getting from its sensor at the same time. And then this simple max altitude is a sketch that I put together. It when you power on the Arduino, it waits for a handful of seconds. It records the base altitude, and then it'll display the highest altitude, the lowest pressure that it that is detected, since the board got powered on. So it's the maximum altitude basically. We can talk about that a little bit later. Jeff says that there's not a files section.
He's probably not he has to join the group to see the files.
Oh, interesting. Oh, okay. I didn't know that. Well, I wonder if we should, if there's a way to unblock that. I'll take an action item to look at that. And what you're saying here is, Bruce and I are administrators for the page, so this is some of the administrivia stuff that you won't necessarily see on yours. Okay, well, we're coming up on 25 past the hour, which was our 15 minutes of terror of trying to get the Arduino installed.
The other thing we can do is, if people have problems, I can, especially like on Windows machines or whatever, send me an email and I'll work it out with you.
Yeah, or Bruce and I both monitor the messages section of the Make It Take It. So that's this messages thing over here. Apologies, there are messages here about when things get changed. Maybe you're interested in knowing when wiki articles get changed, but Bernard's been posting some really good stuff in here about getting the Arduino IDE installed on a legacy Mac laptop, and so there's some really good stuff in there.
One other thing that came up, if you're already part of the NAR group, NAR groups IO, you can join. We're just a subgroup of it, and if you put your request in, I can approve it right away. Unfortunately, somebody had to actually join the NAR group, and I don't have access to approve you there. So you have to wait till they approve you to get into the main group so you can get to the subgroup.
Okay, but I think we tried to make the subgroup completely open so that you didn't have to be a member to view stuff. So hopefully you can actually see some of the content there, and I'll work on trying to get that files section opened up as well so that people can see that. But in the meantime, Ron Logan thinks that there's no file access without group membership, so maybe we're just stuck on that. And but you can email Bruce or email me, message us outside, and I'll put my that's my email address. You can send me an email message if you need access to those sketches and you haven't been approved yet, and I'll send them to you. Okay, well, so let's get back into full screen mode. And if people are still having issues with the Arduino IDE, we can work on that later too as well. We've got the meeting room for another hour or whatever. Now, that display test sketch, because it's talking to the sensors and talking to the display, you need to do a few extra steps after you've successfully done the blink thing. And it's basically you use the tools pull down to go to manage libraries. And then up at the top of the page, there's a menu for doing searching. And you want to search for, I typically search for this last term here. And for the last word, and I usually leave the Adafruit stuff off the front, but then you want to be careful about what package you install, and actually install the ones from Adafruit, because sometimes for these different devices, somebody else has written their own library and they've published it out to the community. So it's wonderful that everybody's involved, but it can be a little bit confused and you know, when you see multiple stuff there. So look for the official Adafruit ones for these 3 different packages. And then the last step there is that we'll load that integrated sensor test sketch, and that's the one that displays all the sensor readings on the display, so that you can just make sure that the display is working and that you're getting sensor values. So this one's pretty quick. And once again, these steps are over in that wiki under the avionics setup. So so this is getting into the Arduino using the managed libraries, ... up top. It pops up that window, and then you use the search function to search for, we'll look for that SSD 1306. And then you'll notice that there are a couple different libraries one, and I chose that Adafruit one. Sometimes these things have subsidiary libraries that they depend upon. Go ahead and install all those. It's a tiny bit scary, but go ahead and do it. And so now we're going on for that BME 280 sensor. Once again, it wants some other libraries to make it happy. And then that LC709203F, that's the battery management integrated circuit. So that's the thing that lets your program read back what the battery voltage and what the battery state of charge is. That's not on all Arduinos. It's kind of cool that it's on this one. But anyway, that's what's going on there. So those libraries got added. And then you can click on that link in the wiki, and it'll try to automatically get the that sensor sketch loaded, and it'll ask you to create a directory for it. That's just the standard thing because Arduino wants to suck those in. And then click on that right arrow to compile and try and load that up to your Arduino. And you can see the red text that's loading. Sometimes if the serial port magically goes away, go to tools, look for the port option in the menu that comes up, and then select that port. It'll say which it should talk about the particular processor board. So we're back again to the point where we can take 15 minutes if people want to, maybe until quarter of the hour, and we'll just monitor the chat if people want to try and load that test sketch. I'm gonna stop sharing. And I'll show you what this sketch should look like on your. So I'm going to go ahead and plug the battery in. I claim I preloaded this with the with the sketch. So what you'll see is you see that little Adafruit splashy thing show up, and then you should have a display that's showing the temperature, pressure, humidity, and the battery state. It's interesting. I see you're seeing a rolling pattern there. So there's some sort of beating of the rate that this thing is displaying those numbers against the video sample rate of the display. So there we go. I have real trouble pulling out these little tiny connectors. You don't want to wail on these wires. Keith from Adafruit suggested using a pair of pliers with bent tips. I put a link in the wiki. There's a guy for about $5 will sell you 5 of these. Postage is another $5. So for $10, you can get 5 of these things. It's a little piece of printed circuit board that he cut to be exactly the right size for a JST-PH connector. And so what it does is it slips on there in between the ears of the battery and the printed circuit board. So you put that puppy on there, and then you can just lever it, and the connector comes right out. So I'm thinking of buying another pack of these because they're kind of like guitar picks, right? You never have one when you need one. They like grow legs and walk away. So I've got these kind of spread around in my office work room because I use Arduinos at work for stuff, and also my hobby room. But these are really cool. The tweezers are really good, of course, because the connector. Well, you know, this might just work for the oh, it's really too thick for the Stemma QT connectors. So you really do want the tweezers if you're going to be demating these Stemma QT things. Yeah, so Cliff says that they sell the JST extension cables. That's a great thing, Cliff. They sell some if I can get the plastic bag open. Adafruit does a funny thing. They've registered a domain called adafru.it, and so if you put your web browser in adafru.it/ and then the part number like 3064, it'll go to their web page. So that's just pretty handy. So to find stuff. But this cable that they sell has got the mating connectors on either side, so you can do an off and on switch. And they also sell some prefabbed extensions. And so if you want to get one of these, and then you can snip it, and you can, I'm going to say the solder word. This is, you know, we're doing a no solder project today, you know, so I'm just warning you that I'm going to say the solder word that I said again. But if you don't want to buy the kit to try and crimp these connectors, I don't think anybody sells a crimp version, or at least I wasn't able to find a crimp version of this mating connector. And so the easiest thing, if you want to put a nice switch on there for like the switch band of your rocket, so you can turn these things off and on remotely, is buy one of these extension cables. This is adafru.it/1131. I'll put this up somewhere on the wiki, and I'll put up a link to this push button switch. You know, normally we don't really like push button switches in rocketry, right? Because acceleration can do weird stuff to those things. But for these C11 and D12 motors, I don't know that you're going to pull enough G's to actually do anything to activate this switch. So I'll put up these links to these things on the wiki at some point, and you can try that.
Well-
So thanks, Cliff. That was a good reminder. Go ahead.
Yeah, just a comment on those connectors. Yeah, the male connector only comes with the pins, so you have to solder to that. The female connectors, you can actually buy a crimper. There are special crimpers, and you have to have the right one, or you're just going to trash it. And even with the right one, those things are a real bitch to crimp and have them be able to fit into the plastic housing. I have at best, I have a 50% success rate on it.
So can you tell how big a geek I am? So Adafruit sells a kit of these JST-PH connectors. It's kit number 4422. And then they sell it's like $40. They sell the appropriate crimper for that. And these are really sweet if you want to make up that one side of the connector. Adafruit claims that they found a company that has a crimpable version of the other side, but then there weren't any links to it, and so I'm not convinced that it actually exists or that it's available to mere mortals. And so, yeah, once again, really the easiest game in town is to buy the things that they've already soldered. You know, they've done a nice soldering and shrink wrap cover on those pins. At work, we've got, you know, somebody who's been building flight hardware for 20 years, and she can do these things and make them look nice. You know, when I soldered this stuff on it, you know, it looks like a robot threw up all over it. So buy these things. They're like $1 or something. They're just incredibly cheap, and that'll help you out. I will ask. I'll send Todd an email, a text actually, and see if okay, so I sent Todd a message. I'm not sure if he's Mr. Communications, of course, but I don't know if he's involved in that that groups.io thing. I will. Chuck Neff is the person, the sections manager was the person who set up our Make It Take It session over on the groups.io. And so if somebody wants to try and message him over on Chrome, or I will I think I stopped sharing. Let me I will try and send Chuck an email and ask him I'll ask him if he can do that. Okay, sorry to be forcing you to watch me type. Which has got to be painful. Okay, we're coming up on quarter of the hour. I know that Adafruit's been out of stock on this board for a while, and yeah, apologies on that. This chip shortage is just it's really tough all over. I know Bernard had something that he was using. Bruce had another board that he was using. We'll try and get together and maybe offer up some suggestions of some other feather form boards with quick connectors that won't be too painful. And the issue here is that the different feather boards often have different capabilities, and so you can't always just take an The wonderful thing about standards is that there are so many of them, right? So you would think that Arduino software would be standard, but um, uh, sometimes there are features that will run on one Arduino board that won't run on another one. And so, for instance, a couple weeks after I selected this board, they came out with a really cool board with the same processor that had a built-in OLED display right on the board. And I thought, and a quick connector. And so I thought, awesome, that'll be so cool. Maybe we should use that. So I ordered one. Oh, but it has different features. And so the software won't just work. You have to modify stuff. And one of the things that we had wanted to do with this session was try and give people a pretty straight path to walk. That if you buy this stuff and you plug this stuff together in this way, then you've got a good chance of making it work. And so now that you've jumped into the swimming pool, maybe we'll let the sharks in there, and we can open it up to some other architectures and stuff like that if people get comfortable. But we did want to try and limit the possible permutations that could go in this project. So the bad news is that people ran out of boards. Once again, apologies. Okay, so it's quarter of. I am going to share screen again. And you should be seeing my screen sharing. I'm going to go back into slideshow. And hopefully the people who wanted to try this test sketch were okay with it. Now, for flight testing stuff, as Bernard mentioned earlier, you want to vent the avionics base. So this is basically true anytime you have any sort of barometric pressure sensor, your deployment altimeter or whatever. It needs to know what the outside air pressure is. Because air can take time to move through holes, you have to look at the volume of your payload bay. And then there are some online calculators that you can use to figure out how many and how big the holes should be, so that as your rocket flies, the payload compartment accurately tracks the external air pressure. And I think I mentioned earlier, Bernard had written an article in Tim Van Milligan's Apogee Rockets Peak of Flight newsletter that discusses that pretty comprehensively. There's a link to that in the wiki appendix that talks about altimeter venting. Just some stuff. Yes, when I go to the flying field, I bring my laptop computer in case I want to make a last minute change to a sketch or in case something goes wrong. You can certainly do that. But I would encourage you, and most people probably want to load up their software into the altimeter before they leave, just to make sure that everything is working. Try it at home first to make sure that the battery hasn't died and that you know that the sketch is actually working the way you intend it. Um, Charge the battery beforehand. These batteries want to be charged, and there's a wiki subsection about battery charging stuff. The feather board will charge the battery as long as the USB-C power is plugged in. You don't have to be plugged into a computer. If you've got some sort of USB that will, some sort of wall wart or dongle thing that will provide USB power to a USB-C connector, you can hook that up to the feather, and it'll charge that that battery for you. And remember, the yellow light will go out once the battery is fully charged. But you want to charge these LiPo batteries at a fairly low rate because there's not any built-in temperature measurement or anything like that. So you want to be a little bit careful about how these things load. So they recommend, I think on the battery page for Adafruit, that they're recommending that you charge this thing at 100 milliamps. And so it'll probably take a couple hours to charge if it's really discharged pretty far. Once you're getting into these sort of complicated projects where you can get distracted with things, I really encourage you to have a pre-flight checklist. So the Estes green eggs and all the Estes kits have a checklist of things like how many sheets of recovery wadding you should use and stuff like that. But make some notes. You want to make sure that your recovery system is all hooked up at both ends. You know, I've seen level 3 flyers fly their rocket and it gets up in the air and they realize, you know, that they didn't close some quick links or whatever, and that's never a good day. But just lots of generic stuff about being careful. I've had good luck with the C11 motors. The flight's a little bit anemic at about 300 feet, but if there's a little bit of a breeze, that's not too bad. And then the D12.5, I kind of like a 700-foot altitude for this because typically means the rocket doesn't drift all that far, so that's good. Here's an earlier, I'm over at the Novar launch at Great Meadow, and it's 26 degrees out, so you'll see my shivery fingers attempting to plug this thing in, plugging the battery in, which is taped on the back. And now you can watch me fumble my way. You can see that flight sketch comp up at the top. That's a great little altimeter. It works off of Bluetooth, so you can turn it off and on once stuff is installed. And that'll give you a cross-check of the data from your Arduino project. And then, notice there's a little bit of fumbling going on. Sorry for that. Now, you notice I put those removable rivets in the nose cone first, and that's fine. It is a little bit tough to get stuff stuffed into things, down into that aft adapter. So in the way it's currently rigged, you're going to have to pull that plywood out a little bit, and you're going to have to hold the, notice I'm squeezing that aft bay a little bit, and then that STEMMA QT cable is sticking right up in the air. You'll need to gently fold that over a little bit to get it into the aft area. And then you can try and put those pins on. But then I can run this thing on the battery for a couple hours. So you can do that stuff back at your car while you're getting prepped. The baseline reading, and let me go to the next slide and see if I actually talked about. No, I didn't. So what this code currently does is it's really basically just the minimal possible maximum altitude code. So there's a little bit of a countdown on the display where it shows you the pressure, temperature, and humidity, and the battery status. And at the end of that, it remembers what the pressure at the launch pad is and what the temperature is at the launch pad. And those numbers are important for doing the subsequent calculation of going from pressures to actual altitudes. So if you plug this thing in and then wait an hour to fly, or if you plug it in and you're blowing on the pressure bay, on the avionics bay, you may be affecting the baseline pressure reading that got taken at the end of the countdown process, but just before it starts reading it starts indicating the maximum altitude. Now, typically on a professional altimeter, that algorithm will it'll do a bunch of averaging of the pressures and stuff. This currently doesn't do it. I'll probably leave that as an exercise to the reader if you care to do that, or maybe it'll come out in a future reading, in a future version of the software. And then what this code does is then it starts reading the pressure as rapidly as possible from that sensor, and it just remembers the lowest pressure reading that it ever sees from that point on, and it does a calculation of between those two pressures at that temperature of what the altitude difference in meters is. If you look inside the sketch, there's a web page, and you can see the formula that they have in there. Now, I got during flight testing, these 300 and 700 foot altitudes were what I was getting from the flight sketch comp. And I was getting readings on my Arduino good to, I think, a couple of meters of those. And so I was really pleased at that, given that I think that our Adafruit web page says that sensor is good to about a meter. Bernard can comment on this later. I think he put his into a test chamber with a Jolly Logic Altimeter 1 and did a test flight, by pulling a syringe to simulate the decreased pressure during a rocket flight. And I think Bernard was seeing 100 or more feet of difference in altitude there. So this is rocket science, and it's science in general. One of the things that we're going to need to do is investigate that and see what's going on. I sent John Bean an email to ask him how the Altimeter 1 does its altitude calculation stuff. And then I haven't finished it yet, but I'm in the process of doing an Arduino, obviously, controlled vacuum bell jar with a vacuum pump and a relief valve on it and its own pressure sensor. So I'm going to try throwing this Arduino project and a couple others in there and try and get some traction on the corresponding raw pressure readings, but then also on the calculation of pressure to altitude, because there are a number of variables in there about sea level pressure, the reference pressure for the day, because that changes as weather fronts go through and things like that. This demo code uses 1013.2 millibars. That's the normal sea level pressure as the reference. So one thing that might be interesting is seeing is using a reading from your local National Weather Service station as the reference pressure and see what happens there in terms of, when you adjust that for the actual flight day, what that does for the altitude calculations. So, things that we could do down the road. So this board has got a USB-C disk drive interface. So when you plug this on into your computer, it could look like a USB memory stick. One of the things that I'm going to be doing next, and then I'll publish this to the wiki, is to record flight data into files onto that USB memory stick so that you can then download it later on the USB-C to take a look at. This thing has also got a Wi-Fi interface. And so one of the things that I would like to do is download telemetry during flight over Wi-Fi. This particular board does not have Bluetooth, which is what a lot of things like Flight Sketch and Jolly Logic use for their telemetry. So this one just does Wi-Fi stuff. An interesting thing about downloading telemetry during flight is that the NAR has a Rocket Science Achievement Award. It's over in the high power rocketry section of the NAR website, but you don't have to do it with a high power rocket. You can do it on a model rocket as well. And I did confirm that downloading pressure, temperature, and humidity data that you've got on your Arduino BME 280 sensor, if you telemetry that down over Wi-Fi, that would qualify you for getting that Rocket Science Achievement Award. And then one of the advantages of this STEMMA bus is that there are a whole stack of peripheral devices that will let you do things and get additional data. There's a really cool little GPS unit, and I can show that to you folks. It's about the size of that BME 280 sensor. There are a handful of different inertial measuring units. Accelerometers, linear and angular rate, and also magnetometer units. And then potentially really cool thing is your board has got a NeoPixel on it. A NeoPixel is basically a red, green, and blue LED that's got a little tiny microprocessor on it. So you can load light programs into that thing to do various blinking patterns in various colors and intensities. And Adafruit and SparkFun sell a bunch of different NeoPixel light fixtures with lots of different NeoPixels on them that support this STEMMA interface. And so you could do up some pretty cool night flying displays, I think. One of the things that I want to do is, and I started working on this on another Arduino project that has an inertial measurement unit on it, was I wanted to be able to adjust the blinking lights, the blinking pattern and intensity of the lights to match acceleration. So when it was sitting on the pad, there'd be a low blink rate, and then during the high acceleration phases of flight, it would get more interesting with brighter lights and different blinking patterns, and then perhaps a more sedate blinking pattern when it's coming down under parachute. Projects down the road that you can experiment with now that you know how to do software and how to add capabilities to your feather board. This was a flight at Great Meadow. You might recognize one of the horsey jumps there. I actually retrofitted, because we're flying in the winter and those plastic parachutes tend to get kind of stiff. This is a Spherachutes 18-inch super lightweight nylon parachute that's pretty sweet and doesn't seem to have any problems in the cold weather. So I like that a lot. And now I'm done yapping, at least for a minute. I'm sure I'll yap some more in a few minutes, but I think we're back to the point where we could take questions, comments, see if anybody has any problems.
A couple of things, Will.
Go ahead. It's Bernard. Go ahead, sir.
Yeah, I would expect, you know, as you said, I've only done this bottle test, and I actually, while we were talking, I did the old put it in your hands and suck on it thing with the sensor board in the middle of the chain. and that same altimeter one, and I even doing that, I'm 100 meters off from one to the other. I would expect to get the same results with anybody else's contest approved altimeter because they all have to conform to the same calculations. So I'll do that and experiment with that. So I'm not sure where the concern is or why I'm seeing such a huge discrepancy, but we're going to have to figure that out. I don't know whether it's base pressure or base temperature or something in the assumptions that your code is doing that the commercial guys don't do.
Yeah, what's
So there's going to be
interesting.
some fun. Go ahead.
Yeah, so this is great, and the software is published, and I could easily imagine that that there are some bugs in there, and I know for a fact that there are improvements there because it's not doing any filtering. That base altitude, it's grabbing the single last pressure reading and temperature reading in the countdown period. Normally you don't want to do that. Normally you want a nice filtered altitude and stuff like that for that baseline reading. So yeah, it'll be really interesting. The data point that I have at this point is those 2 flights with the flight sketch comp where I got maximum altitude readings that were within 2 meters of each other, not the 100 meters that you're seeing. And so there's something going on. And it'll be interesting to find out, what the issue is with that.
Well, I'll try it with a flight sketch in my little bottle if I can't get out to fly sometime soon, and see if I get the same results. But I will be shocked if they don't. If the flight sketch and the altimeter one don't come in within a meter or 2 of one another, notwithstanding what the Arduino thing will do. And
Yeah, I think
you mentioned. Go ahead.
Because the flight sketch has got accelerometers in it, and I don't know what he's doing in terms of his maximum altitude. If that's part of the Kalman filtering.
Oh, it
is he
might be
just
part
doing-
of the filtering.
Yeah,
It might be. I'd have to ask Russ, but there again, I mean, all the contest approved altimeters do pretty much the same thing with their altitude calculations. And my experience has been if I can put 6 different brands in the same rocket on the same flight, they'll all come back within a foot or 2.
Excellent. Okay, well, great. So I think it'll be really interesting to see. So we can do that with those 2 altimeters, and we should double check the code and see what's going on. Yeah.
Yeah, I have a
There
feeling
could be
it
a
has
bug in
something to
there.
do with the base. Yeah, I have a feeling it has something to do with the baseline assumptions. But I haven't had time in the last couple of days to go dig into that. You talked about telemetry a little bit and suggested that the flight sketch devices do telemetry. Of course, that's not the intent. I have been known to get a flight reading on my phone as the rocket descended over my head, but it's not set up to do that. So that would be a great extension of this, I think.
Yeah. So and Wi-Fi. So we could play with that. I think it'd be a lot of fun. Okay. I see Tom Broad. You've got your hand up. Do you want to unmute and say something, please?
Yes, and I apologize. I don't have my video working, so you'll just get to hear my voice. I didn't have access to the B&E 280 sensor, so I dug through my parts box and found a DSP 310, which is a lot more sensitive, and it also has the ability to calculate internally altitude, which I was able to read. So what I actually did on my sensor setup was to monitor the internal altitude setup and then use the calculations we were using and put them side by side and for comparison. And what I found interesting is our calculations are very temperature sensitive. I was doing simulated launches. We have about 2 feet of snow here in the Northeast, so I was inside, not actually launching. My simulated launch was to run from the basement to the 2nd floor. And as I was going from the cold basement to upstairs where it was warm, you could see the altitude changing much quicker. I calculated AGL, from the base. so I could see the above ground level from the basement. And the altitude of our calculated increased significantly faster than using the internal one on the chip. And in fact, then I noticed if I simply put my finger onto the chip to increase the pressure, the temperature, I could see the altitude increasing. And so I think there's something happening in the calculation that we're using for the standard atmosphere that's throwing our altitude off, perhaps.
Yeah, so if you look in the code, I don't think I put the URL anywhere else, but if it's in the bottom of the of that simple max altitude thing, I found a web page that looks authoritative to me, with a formula for calculating a relatively simple formula for calculating altitude above sea level based upon temperature and the reference pressure, and then the pressure measured at your location. And so that's what that code is doing. And so it would be very interesting to know if that page I found is perhaps wrong or not the best thing to be using. And of course, the other consideration here, and that web page goes into it, is that the calculation that I'm using is only good for up to 10 or 11 kilometers. And so you get above that, and then atmospheric pressure starts doing sort of weird things, and temperature, and you have to start doing other techniques if you want to go to high altitude. So I got totally lazy and just used that basic low altitude formula, because with a C and D motor, I didn't think I was going to be able to get up 10 kilometers. But I'll buy somebody a soft drink or maybe even a beer if they can get up to 10 kilometers on a D12 and a green eggs. I'll be really impressed.
Yeah.
Well, I have
I
used
might
that. Yeah. Well, I have used that same formula trying to calibrate my vacuum jar for testing, and it seemed to be accurate. So I was just wondering if maybe it was some temperature effect that was happening that was throwing us off.
And that's probably it, because all commercial altimeters assume 15C, and then we correct at the field at a contest after the fact with whatever the ambient temperature is when you turn in your flight card to go fly. And I saw in the chat that somebody commented that's kind of ironic, but the reason that we don't rely on the sensor or on the temperature that the sensor is seeing is because the temperature inside your rocket is not the temperature of the ambient air, especially when you've got a whole bunch of electronics packed together on a microprocessor running. So the way to do that, at least that's the current best thinking on that, is to just assume 15C and then do this calculation after the fact. And Contest Manager's got the calculation built in, so all you have to put in is the reported altitude and the ambient temperature, and then your score gets fixed in Contest Manager, which is how that's done. But I was suspicious that maybe that's what's going on here, except for, inside the house is not that much. It's a little warmer than 15C, but not a lot. And so far the numbers I've done are just in the house. So as they are with Tom's. So yeah, I'm gonna have to go out and fly this thing, but I'm going to look at that code and see if that's maybe part of it, is this temperature assumption.
Yeah, so the code does not assume a temperature. What it does is it actually uses the measured temperature at the time of, from the sensor itself. And as you say, that's not probably the right thing to do, given that the vent holes that you put in the altimeter bay are appropriate for equalizing the pressure internally and externally, but as you point out, they are not appropriate for actually measuring the environmental pressure that is what's the determining factor in the altitude calculation. So I can certainly, and it's a trivial exercise to go in, and you'll see at the end of the setup loop that there are a couple of global variables. There's a base altitude, pressure, and a temperature reading, and you can just instead of reading the number from the sensor, put in 15 degrees C there. I think it's in kelvins, and so you might have to do the subtraction. I don't remember.
There's I'm looking at the code, and yeah, I see something that says float the temperature, and then the comment says degrees C. Is that the spot where I would just change it, or let me look a little further? It's been a long time since I've programmed, so it'll take me a while to find the right spot. But yeah, I was thinking to actually make that change and try it again.
Yeah,
Thinking about
I
this.
think that'd be awesome, Bernard. And I can make it for you, or I would need to look at the code because my brain is getting fried at this point.
Well, since the whole point of this exercise is to learn how to do this, I'll at least attempt to find it myself, even though I've never written in this language. And I'll cry for help if I need to, as you well know.
Perfect. That sounds good. And I think that is an excellent thing. And I bet you've honed in on what the issue is with this. So
as far as the comment in the chat about contest approval, the filtering is a big deal from all the vibration and shock around the ejection event and what you get, especially if it ejects early. So the code's going to have to get a little more sophisticated before you can hand this over to Dan Wolf and ask him to test it and get some contest approval for it. I think I figured that was a facetious comment, but I thought since I saw it and I'm talking about this that I'd comment on that.
Yeah, this is
it's
really
too big and heavy for a contest anyway.
Yeah, when you look at the flight sketch, comp and the
Isn't that an amazing little device? Yeah.
Spectacular technology, just
less
really
than
amazing.
a gram for a Bluetooth recording altimeter. It just blows me away.
Yeah, but I think but the reason why we picked this Arduino package is because it's accessible for you to do what you want with it, and if you want to add some servos to it, to do some stuff, for instance, Tim Van Milligan in the manufacturers forum was talking about his radio controlled recovery parachute that we hope is going to be coming out in a few months. That's servo controlled, and so if you don't want to hook up your radio control transmitter to that, if you instead want to hook this Arduino up to it and get one of those GPS receivers and then do your own return to home gliding parachute thing, you've got the tools to do that, and it would be solderless. Now, filtering, getting that steering stuff down and filtering the GPS stuff is, I think, probably deploying the parachute reliably without getting any of the mechanisms damaged is probably the big mechanical technical hurdle of that project. But the other challenge of that return to home gliding parachute thing is filtering GPS sensor values in a rational fashion. So I think it'll be awesome. You could totally do it with this project, with this Arduino setup that you have, and by adding that $20 or $30 GPS receiver. I'll put some links to this stuff in the wiki at some point, and I think that'd be an awesome addition. And the fact that Tim's going to be sending that out as a product that does radio control stuff would allow you to refine your technique for getting the parachute actually deployed and learning a little bit about how the thing glides and behaves before you try to do autonomous return to home. stuff. Anybody more questions, more comments? We've got we have another 40 minutes of time before the competition track starts. So we've got plenty of time to yap about stuff if people are interested. If you don't mind me disappearing for just a moment, I'll go grab that GPS, that quick GPS thing, and I'll hold it up to the display for you.
I guess I'll yap so we don't have dead air.
Excellent. Go for it, Bruce.
The again, just to remind everybody, this this isn't kind of like a finished product. This is, I mean, there's a lot of people who are, the technology's out there, and you see these articles in sports rocketry that they build it, and it's like, well, there's a big gap. It's like, how do I even get started? And this program is sort of the niche that's saying, okay, the hardest level, the biggest jump is getting the environment set up. And even Tim was complaining in the manufacturer's forum that each of the platforms, they upgrade something and it breaks stuff. So the hardest thing is getting the IDE until they get to a web version of the IDE that works across all the platforms. You're kind of stuck in this, figuring out what the platform is to get it installed. If you can get past that hurdle and you see the code, even if you have a basic understanding of programs, you can go in and just diddle, do the what ifs. If I change this variable, if I change that variable, that's probably within the scope of most of the people here, even if you don't do programming as a living. So that's pretty much the main intent of this.
So Altus Metrum, for instance, they publish their source code. It's all open source stuff. So, and they also publish their hardware design. So if you want to go off and make Altus Metrum hardware on your own, you can do that. I think the cool thing about the Arduino platform and this project in particular is that we're giving you the capabilities to add on extra stuff to do what you want to do. And we're also giving you the capability to do the source code to do whatever it is you want to do. This Adafruit Stemma QT GPS, it's part number 4415. Okay, wait for it. That's it. That's a GPS, postage stamp sized. So that's basically the same size as the pressure sensor. And there's room on the back if you want to solder on a little battery holder for so that the thing does faster startups. But this is pretty cheap, and they still had them on the Adafruit page. So there you go, full up GPS, GNSS navigation system to add to your Arduino if you want to do, if you want to add GPS stuff to this. Lots of other stuff you can do because it's got Wi-Fi. If you have Wi-Fi at your field, you can, this thing can connect up to the internet and it could download data automatically to the internet. It could connect to your NTP server. There's Arduino libraries to get date and time stuff so that you can accurately timestamp data. Currently this thing just wakes up. and it knows about the amount of time since it got powered on. But I've used some Arduino stuff that goes out over Wi-Fi and gets the date and time, so you get good good sampling, good time tags on your sampling. So Tom comments about using that board. I saw a comment. I'm sorry, stuff is going in about the 1 hertz sample rate from David. Yeah, of course. So GPS stuff isn't all that accurate, and so what I think you're going to want to do is you're going to want to take all your GPS stuff, your IMU stuff, and run it into some Kalman filter to try and get more precise navigation information. And a 1 hertz GPS might be fine for that to to update your IMU settings, which are going to be the things that over the short term are going to give you the higher accuracy, but over the long term are going to tend to drift. So I don't know. Maybe 1 hertz might be okay for putting together a nice little integrated IMU system. I'm not sure. So I look forward to reading an article from you, David, in a future Sport Rocketry magazine about how you put that stuff together and got it to work. I think there are lots of opportunities here for articles for Sport Rocketry, for some NARM. Yeah, David's commenting that about his copious spare time and getting stuff done, and that's welcome to my nightmare. But I think there's a lot of cool stuff that we can do with this to get you out to the flying field and doing something out there. And it's always fun to just burn motors, but I think it's a whole lot more fun if I'm actually doing something with the payload. There you go. What else do we want to talk about? I'm going to share screen again because on Saturday there was a and I'm sorry, my brain is turning to mush. I can't remember the person who is doing the level 1 build session for the rocket using the SBR Fusion 3-inch. So
James
I showed
Crampton
this
from Rocketry Works.
Excellent. Yes, thanks, James Crampton, Rocketry Works. This is the base board of the sled. You can see it says SBR laser marked on the side of it. That's the main board for the sled, for the 3-inch Fusion, the vNARCON kit. And this was just a notional layout of how you could put these Arduino boards onto this thing and then fly this payload on the rocket that you might want to use for a level 1 flight. You could the rocket's probably light enough you could probably fly it on maybe FRGs if you're lucky. Notice I put the OLED display in the middle because there's structure at the forward and aft end of this avionics bay to form the bulkheads, and so it seemed like the OLED display might get obscured by some of that structural stuff down there. You might also want to move these parts off to the side or try and congregate them in one portion of the board so that you could also add a commercial deployment altimeter in case you want to do dual deploy on this puppy with an avionics bay. This rocket's perfect for a Jolly Logic shoot release, of course, but you could also do a more conventional, maybe a one compartment dual deploy with something like a Peregrine line cutter or something like that. Anyway, so I just wanted to share. Oh, so this is board size compared to that battery that we had you buy for the Arduino project, and then the sort of raw avionics sled Sauvage, the raw plywood before the mounting hardware had been fixed to it. There you go. I have a few of the green eggs and ham rocket kit. Does anyone have one built with the sled and parts in it that they could show on screen? Bernard, have you put the altimeter bay together?
No. Here's the
me-
Arduino. And there's the green eggs. They're not yet integrated.
Okay, let me share my screen again. And let me put these slides up. So can you see that slide okay? So that's the green eggs rocket. I'm sorry it's not painted. Once again, I'll echo David's comment about not having enough spare time. But that's the sled mounted inside that puppy. And that's sort of a close-up of what it looks like. This isn't exactly in flight configuration because I don't have enough masking tape on the battery. There was only one strip of the 1/4-inch masking tape on this. And you'll notice that up at the forward end, towards the top of the screen, the flight sketch mini altimeter wasn't stuck on there yet with double-sided tape. Let me see. That's another picture of the whole rocket. That's the avionics sled on the right, and that shows the flight sketch comp with just some double-sided foam tape taped to the top of it. I did it up there because it's happy being hidden by the nose cone, but you do want that OLED display readable in the payload bay, so that's why I stuck it down a little bit lower. And so, this is sort of the raw green eggs rocket on the left, and then the avionics sled in the middle with the mounting hardware on it. A weird thing about that Arduino board is that the two little holes that are up at the top end next to the Wi-Fi antenna, those are M2 sized holes. All the rest of the holes for all this stuff is M2.5. And so you could probably take some of the M2.5 hardware and maybe sand it a little bit, or maybe you could screw it down through those holes so you didn't have to go out and buy some M2 nylon hardware. But I just went on to Amazon, I think. There's a link in the wiki page, and I bought an M2 nylon standoff assortment kit.
I'm just going to use M2 on all of it when I put it together.
Did you?
Sure
Yeah. Okay. That's perfect. Yeah.
That's certainly in this model, and even if with an Aerotech F44, that's going to be plenty.
Yeah, it should. That's a great comment. It should be fine. And another comment is I used those kits that I referenced come with multi-height standoffs, and I used the 1/4-inch standoffs for all this stuff. But you might want to think about if you have trouble reading that OLED display through the green translucent Green Eggs payload bay, you might want to try putting the OLED display up on one of those taller standoffs to get it up closer to the to the perimeter of the payload bay, and see if that makes it a little bit easier to read. I was able to read it through that green, that translucent green payload bay that's a stock one with the green eggs. But I really didn't like it, and so I bought a couple of the Olympus kits from Hobby Lobby, and I scavenged the payload based stuff out of there, and I've been using that because I prefer that transparent, well, or much more transparent, clear payload bay on the left. It's the Olympus one as opposed to the stock Green Eggs one on the right. I was encouraged to hear that John was that Estes is going to try and come up with more spare parts, because I tried contacting customer service to see if you could just buy the Olympus payload bay, and indeed you can get that white nose cone aft transition thing. But what you can't buy from Estes is that clear BT65 payload bay. At this point, the only place you can get it is out of one of the Olympus kits. So I'm hoping. And
here's the green.
the
Here's the display up against the green, to just very right up against it. Just
let me stop sharing for a second, Bernard, and then. Yeah. So are you able to read it through there? I was pretty much able to read it, but it was kind of a.
Yeah, that's not bad. In fact, it looks like for me, except out in the sun, maybe, even down on the sled, kind of the way you've got it mocked up or way you've been flying it would work for me, even in the green. But yeah, you can get it a whole lot closer, and it makes it a little easier to read. I'm just looking at it in my hands right now.
Yeah, and I tried some of the BT65 transparent payload bay from Semrock, from eRockets, and it's a little bit small, and I didn't think that I would be able to sand. Maybe you could sand off the inside of that Semrock BT65 and those plastic nose cones a little bit and get it to fit. But I didn't go that way. It was just easier for me to get the to buy an Olympus. Leland, did you have a question, sir?
Which end was too snug?
Yeah, I've got a completed one here that I put on a board to go into a Concept 75 fiberglass rocket in a 29 millimeter bay. So I put one together. I've got to flip the sensor, like you said, to put it face down. Everybody see that?
Yes.
Sweet.
Came out
And
pretty
it
good.
looks, and I'm seeing the battery connector next to one of your fingers. Are you doing
Oh,
a
let me
remote?
turn it over.
Yeah.
I
Okay.
just cut a slot through the board. That's it.
Okay, great.
Yeah, that makes a lot of sense.
Yeah.
So this is Ken Waver. I don't see that my questions comes up in your question board, but how much of this is applicable to, I work with a couple of TARC teams down here in Tucson, Arizona, and they use ESP32s and Raspberry Pis. How much of this would be applicable to their work?
Well, of course, it's not one of the official altimeters that you can use for the required altimeter reading, but you could certainly use any of this stuff for deployment, or the altitude control stuff that I hear a lot of TARC teams using. So yeah, this is an ESP32 board, so they probably know more about it than I do if they've actually been flying this stuff in TARC competitions. So But this is exactly what we're talking about.
Yeah, we're trying to get combine the TARC group or get people from the robotics group to work with the TARC group and vice versa. And so the robotics people have a lot of experience with this stuff, and the rocketry group not so much.
Since last
Yeah,
year's
that's
TARC winner
perfect.
absolutely did that with their active drag flaps and their active little fans that they use to adjust the altitude. Clearly, that's the wave of the future, at least until Trip disallows that kind of thing in the rules. I was there when we saw that flight. It was flown at Pasco, Washington, and I was there, and it was just an amazing thing, just an absolutely amazing thing.
Very cool. Yeah, you know, we really are in a golden age of rocketry with all the motor stuff that's going on, all this electronic stuff that's going on. It's just really, it's a cool time to be in the hobby. I'm going to go grab a piece of that BT65 transparent tube. I'll be right back, and I'll show you.
Yeah, I'm surprised that he found it too tight, because I had to build up the shoulders of both the nose cone and the payload adapter, especially the payload adapter, to get it tight enough on the parts that come in the kit, both with the Olympus and with the green eggs, since they're identical physically, just different colors. So I'm kind of surprised that PST 65 from eRockets is too tight. So, well, you didn't hear me chatter while you went out of the room. I had to build both of those shoulders up with clear tape quite a bit on the green eggs to get them tight enough. So I'm kind of surprised that the PST 65 doesn't work, especially on the bottom. The bottom is looser than the top.
See, it's like the outer diameter of this Semrock BT65 is like the inside diameter. Yeah, the outside diameter of this BT65 from Semrock is almost the inside diameter of the Green Eggs altimeter bay.
So it probably sort of goes on the base, but doesn't take the nose cone at all.
It doesn't. Yeah, I can't get it on the base. You know, so of course these things come together. So the base and the nose cone are pretty much the same diameter, and they're awfully thin. You know, if this was balsa wood, right? You know,
Oh yeah, it'd be easy.
I would just
Yeah.
sand it down some. But I didn't want to go after this stuff, and then I started thinking, you know, well, I could sand the inside of this transparent. You know, I could spend 2 hours of my life sanding the inside of this transparent bay to try and get it to fit, or I could go to the website and I could just order a couple of Olympus kits from Hobby Lobby, and they would be here in 2 days. And so I totally wussed out, and yeah, that's what I did. So now I've got extra components, but so it goes.
So you should fly it on the Olympus, and then you can put an E into it, since the Olympus has the longer motor mount.
Well, you know, as I said, I got this Fusion 3-inch kit, and I don't know if people have seen it. Sorry to keep disappearing on you folks, but okay, limited edition 3-inch Fusion vNARCON 2022. So I think it's 38 millimeter motor mount. I don't remember now. I think it's 38 millimeter, and
it's 29 millimeter motor mount. And the James Crampton put up in the thrust curve his build version of it. So if people wanted to look at how he built it. He has it up in the thrust curve.
Okay. The one I've got, I don't know if I got a weird one or something. This one came with a 38 millimeter mount and a 29 millimeter adapter.
You're
So-
correct. I was incorrect.
Yeah, oh, no worries. But anyway, so I'm thinking a J350 in this puppy, and you know, and go after the other rocket science achievement award of the 1 mile altitude thing. And how now, you know, the Wi-Fi range is probably not going to be good enough to get Wi-Fi for that entire flight, unless you put a gain antenna on your Wi-Fi receiver on the receiver side, in which case you might be able to get a mile straight up. But how cool would it be for you to be the first person to do 2 of those rocket science achievement awards at the same time? You know, both the telemetry one and the break a mile one. So I'm sensing a little bit of a space race glove being thrown down here at vNARCON to see who can get that done. I think we've got 15 minutes left. I assume people are having fun because we've still got 46 people here. David Kane is saying Pringles can antenna. Yeah, exactly. Yeah, gain antenna for Wi-Fi might work. Oh, and
Hey.
Ed suggesting for that clear BT65 tube, I could try soaking it in really hot water and then pressing it on to the nose cone sections to see if it'll expand out enough. Yeah, I'll give that a try, because at this point it's surplus through my requirements, so I can see how it works.
Hopefully it won't shrink.
Yeah, well, I've got these extra green eggs nose cones too, so you know, if all those parts end up destroyed, then I will not be distraught. So I'll give it a go and I'll report on that. So
Hey, Will.
oh, go ahead, Ed.
I know you showed the limited edition Fusion, and I wanted to note that when Lock Precision made that up for us, they're throwing in the AV-based sled at no additional charge for members who order that limited edition kit. Otherwise, normally you have to buy their AV-based sled as a separate item. So that was a perk that we got with that limited edition kit.
Excellent point. Right. So that'd be a fun little project.
Yeah. Yes.
Where
do you get the kit?
Sorry, not Lock, but SBR. My bad.
Yeah, and I just went out and looked at it, and it is a 38 millimeter with a 29 millimeter adapter.
Yeah, it'll be a nice kit. And let me see if I can. I'm looking. Here it is. 3-inch Fusion Narcon limited edition, $79.99 for level 1, or I put the link over in the chat.
As did
And,
two others.
Okay. And there's a nice photo there of the completed avionics bay up on the website. So I think some people are waiting for their groups.org permission to get in. I put my email address up earlier in the chat. I will put it out once more. If you want to send me a message, if you have issues about getting in to the groups.io site, which is, and I'll put the URL up for that as well. And it's up on the description for this talk. And the intent is for that to be an ongoing resource for you folks to come and get support and to ask questions and you know, share your thrills of victory and your agonies of defeat. And as far as I know, it'll keep on going. I will try and yeah, I've been flying these Arduino projects for a couple years now, so I intend to keep adding the stuff at least that I'm interested in. If you put together something cool and you want to put it up on the group, you want to get it posted in the file section, just let me know or let Bruce know, and we can put it out there. Um, 10 minutes left. Do we have anything else we want to talk about? If you go to Adafruit, you can sign up to get notified when those products are back in stock. There are some vendors who carry Adafruit products, DigiKey, digikey.com. I looked at all these and they're out of stock there too. But I'm just saying for future purposes, if you want to try and find some Adafruit stuff, you can look at DigiKey, Mouser, MOUSER, .com, Arrow Electronics, arrow.com often has some stuff.
Will,
So yeah, go ahead, Ed.
David Kane had mentioned in the chat about his frustrating search for small 2S lipos. And I use a lot of different small, both 1 and 2S lipos in my RC soaring pursuits. And people who aren't familiar with AliExpress, that's AliExpress, which is one of these gigantic China sourcing websites. I mean, you'll see everything from women's wigs to every LiPo battery under the sun. If you go into AliExpress and do your due diligence searching, you'd be amazed at what you can find in the way of LiPos. The costs are phenomenally low, in my opinion. And though you have to order and wait maybe a couple of weeks for a small package to make it across the pond, I haven't been stiffed for anything. It comes well packaged, and I found it a great resource. But be careful. You may get notifications from them about, you know, hey, look at the latest thing we've got. Like they may fill up your email box with that. So be careful when you register with them to, you know, use your notifications wisely.
Yeah. Two comments on that. The batteries from Adafruit, I haven't seen those be out of stock. And so so send me an email if you're having trouble finding batteries for this project, then let me know and I'll put you in touch. Now, because there are 2 wires on battery packs, it turns out that there are at least 2, exactly 2 standards, as it were, for the polarity of the connectors on those battery packs.
Even if they use the same connector.
Even if they, exactly. So for that JST-PH2 connector, it turns out that Adafruit, SparkFun, and Altus Metrum, it turns out, use the cell phone industry standard, which has got the hot wire on one side. The hobby community tends to use the hot wire on the other side, of course. So just when you buy these batteries, excellent, search for value, search for the capability you want, but take a look at those puppies and make sure that when you so if you look on the wiki, there's I talk about this a little bit, but this is one of the
because I complained to him about it.
Sorry. Thanks, Brent. I do appreciate hearing stuff from people about stuff like this, because it's maddening. You would think that there would be a standard for the polarity on these JST connectors, but no, in fact, there is not. So if you're looking into the battery and the little ridge is on the top, then the red wire is on the right hand side. So this is the little ridge is on the top. The springs on the connectors are you can almost see it there. So this is sort of the back side of the connector, and the 2 little silver squares there are the springs for the metallic contacts. On the back side of this is the little ridge that keeps you from plugging the thing in the wrong way. And then if you look at it like this, you'll see that the connectors are offset towards the side that has that little ridge on it. And so when the ridge is up and you're looking at the right hand side, looking into the connector, red is on this side. So Altus Metrum uses that standard, as well as SparkFun and Adafruit. The thing to be careful about is you can use the Altus Metrum batteries in this project if you want. Altus Metrum batteries have the protection circuitry taken out of them because to run the initiators for your recovery system, they need a huge current dump to guarantee that those things will fire. And so they have special batteries that don't have the protection circuitry in there that you normally put in LiPo batteries to keep them from blowing up. The batteries you get from SparkFun and from Adafruit have a little protection circuit in there that will that'll stop the power output of the battery if it gets down below like about 3 volts, and they'll also protect the battery if they get charged over about 4.2 volts, and they also limit how much current will get pulled out of these things. So when you buy batteries from Adafruit, if you're an Altus Metrum flyer, make sure you label your Adafruit batteries and make sure you label your Altus Metrum batteries so that you don't swap them. Because you'd probably be okay with an E-match, right? You know, those just need like a ½ an amp or something, so you'd probably get away with it. But if you're using some sort of nichrome-based Christmas tree light or Doug Pratt's ejection cartridge things, you know, that have a little nichrome wire in it, you might be in for for an unpleasant surprise, because the continuity would look good, of course, you know, so you'd pass a continuity test, but when you actually tried it, you might not get an event. So
What's the milliamp hour on the battery you're using?
this one is 3.7 volts, so it's one cell. It's 400 milliamp hours.
Oh, thanks.
And I was getting about 2 hours out of that with that display code running, that, you know, the code that samples as rapidly as possible and puts all the sensor readings up on the display. I could get about 2 hours of that before the voltage got down to about under 4 volts or something like that. And then something weird was going on where the Arduino was resetting. You know, it should be good down to, like, you know, down into the 3.5 volt range or something. But these ESP32s seem like they're sensitive to low battery voltage. And this particular one seems like it gets upset if you get down around 4 volts. So the good news is I was seeing 2 hours out of that, which was enough for me to do a couple of flights and, you know, the usual messing around on the field and yapping and getting distracted and stuff without having to do a recharge in between. These boards, these ESP32S2s are relatively new. They came out last quarter of last year, so they're 4 or 5 months old. The code for them does keep getting updated by the manufacturer, and so I'm hoping that this battery thing will get fixed eventually. But I think for our purposes, you know, we're probably okay. And so it's
Any
3
idea
o'clock. Oh, sorry, go ahead.
I was just going to ask
Bernard?
you if you had any idea how much more current it draws when the Wi-Fi is active.
I don't know. And so I have not tried the experiment of running the Wi-Fi to see
Yeah, Cliff has a comment in the chat.
how long it's going to draw it. Well,
Oh, well.
yeah, Cliff thinks 400 milliamps is too small. You can certainly put larger batteries on there, and you know, I picked this size because it was nice and small, and for this application, it would be okay. Adafruit certainly sells larger batteries, and Altus Metrum has got some pretty humongous battery packs that you could get as well. So, so there we go. So we're at the end of our time. It was lovely. If you have comments about how well you think this Make It Take It worked or didn't work, let me know, or let Ed know, or let Bruce know. But tell us what you think worked, what you think needs to be improved. Tell us if you even think we should try and do this again next year. You know, this is awfully different from being in a room with people and being able to wander around and see what people are working on their desktops. But hopefully it was something. I can hang around some more, but there are some excellent presentations going on dealing with the competition stuff. And I would encourage people to start thinking about the internets in Texas next year, because that should be pretty cool.
Thanks so much. It was fun.
Great, thanks. I really appreciate everybody. Stay in touch on the wiki, and we'll see if we can't do some more fun flying with this stuff. Hey, Bernard. Bye. So I'm not sure what else I have to talk about. Bernard was having troubles because he didn't have a USB-C to USB-A connector So we found a couple of cables. He found a nice little dongle, and I put a link to that up on the wiki about USB-C cables. This one is fun because you can plug it into your Raspberry Pi on one side, and then you can plug the feather into the other side. And I was actually using my Raspberry Pi 4 to compile code and downlink stuff. And I don't know if any of you have experience on the Raspberry Pi, but it's incredibly cool. It's basically a so this is a little portable Raspberry Pi system that my wife and I put together for her students. And the coolest thing about the coolest thing and the worst thing about Raspberry Pi are that they run Linux. And so Linux is incredibly cool, but there's a lot of stuff going on in Linux. And so I don't think you would want to use Linux, a Raspberry Pi based thing for something like this project where you want everything to be very deterministic uh, and uninterrupted by other things going on like disk accesses and stuff like that. On the other hand, Linux is incredibly cool because it's programmable and it's got text editors and web browsers and all this other stuff. And they make feather form factor Raspberry Pis now. So if you wanted, you could fly a Raspberry Pi instead of this Arduino. Arduinos are nice because they tend you can multitask on Arduinos, but you tend to write a little very simple program and it just does one thing. And so it's very predictable in terms of what in terms of its behavior. But anyway, so this Raspberry Pi that we put together for Ann's students has got a GPS shield on it, so it knows where it is. And then there's a temperature humidity sensor probe, and we had the students code this puppy up, and they were walking it around campus and recording temperature and humidity readings, and then generating maps of temperature and humidity stuff around campus. So it was a lot of fun. But you can put together a Raspberry Pi computer for under $100, and if you have a display monitor, a keyboard and mouse, you then have an Arduino development platform, and you can load the Arduino IDE down on this. Bruce and I have got some info up on the wiki about how to get that running. And then bang, there you go. You've got a development environment for your Arduino. And these things tend to have Wi-Fi on them as well. So you could run your Raspberry Pi as a Wi-Fi hub to get telemetry from your Arduino project. How cool would that be? And then this thing, you can run Raspberry Pis. They're pretty frugal in terms of battery. So you could, take it out to the flying field and use it instead of your laptop computer to do updates to your code, and also to do your telemetry command and control stuff with your Arduino. Yeah, so I see lots of good stuff in the chat about Raspberry Pi stuff. It's another example of just an amazing enabling technology, because the Raspberry Pi stuff, while it's not as good as your laptop, as your high-end laptop computer or your desktop computer, it's really just amazing how much stuff you can cram into a Raspberry Pi, and it's a full-up computer. You would have, back in the 80s when when I was at school, you could have run a university campus on the computing power for these things. It's just amazing. Okay. Are we still having fun? We still have people here. Lucky 13. Bruce, are you gonna do any Arduino projects? What's next on your Arduino horizon?
Actually, I have started working on a GPS locator system. I'm not going to use Wi-Fi or the Bluetooth, but I am going to use LoRa and have have a Spark Fun makes a nice little LoRa board, and it has a quick connector on it to a similar size GPS unit like you saw. So it just fit the same rocket size type, and you have a base. You'll have to build a rocket part and a base part with a LoRa receiver, but then you can use your cell phone to actually display the data that comes from the base unit and give you, like, with the mapping and
Sweet. Sounds like a really great project. Are you going to write that up for Sport Rocketry, or?
I don't know, like, where it fits best. I thought of maybe, like, or even making it part of the add-on to this, or
Sweet.
if we do something, try to keep it in that same, even though it's a little bit more complex. I picked both the base station I sourced from AliExpress. It has a LoRa unit that's built into a chip with a display unit and the ESP32 chip. So it's like basically one chip. And so with just those two parts.
I was going to show this because Bruce is talking about feather wings and and basically Arduino shields. So this is these boards are feather form factor boards. They're the same size as the board for the for that product. This is something I put together for one of my wife's classes where her students were flying drones and needed some precise navigation stuff that they couldn't get out of the DJI software. So this these shields actually plug together, and this one is got GPS on it, and then this is an Arduino, and it's got a little SD RAM card on it, so you can store 32 gigabytes of data, and then these things will just plug together. And so now you've got a little integrated computer with a GPS, and it'll do 32 gigabytes of storage. Bruce is adding, a little shield on here that's got that radio transmitter receiver. What's the range on the LoRa stuff, Bruce? It's like tens, hundreds of miles line of sight, right? Long distance. Oh, sorry, you're muted.
Yeah, I'm sorry. It is line of sight. You can go like a couple miles.
Okay.
So, which is most, because most of it's like, in the air. So, you can see it like pretty far. Once it gets on the ground, like any, we're in 900 megahertz. So you can probably go a mile or one tree. The high frequency radios get sucked up by organics. So, but it will get you close to the spot, and then hopefully, you get back into line of sight again of it.
Yeah, that's the classic point of, you always want to be able to recall what your last good position was so that you can then go there and have a hope of starting to pick up your telemetry again. What else? Anybody have any other questions? I know I'm starting to fade a little bit.
We have one comment here that says, great job, looking forward to working on the project. Yeah, like, it doesn't end here. We can keep this going. And even if there's enough interest, we can set up, I have access to a Zoom account that, if we wanted to, we could meet periodically and, just, not so formal, but just blue sky things, and or just show off, what you're working on, and how far you got.
Yeah, that's a great point, Bruce. We were talking last year about having some sort of a, Saturday afternoon get together thing. So folks who are left, think about, if it would be useful to have a monthly, let's say, couple hour get together to maintain enthusiasm and momentum, or ask questions or something like that. Because we could certainly make that happen. So once you get on to the groups.io thing, see if make that suggestion if you think it'd be interesting. Yeah, Tom says thinks that sounds good. Coordinate through the NAR group posting. Yeah, I think that's a great sort of watering hole for this stuff, Tom. Is this make it take it area, and go ahead and post something up there in the messages, and we'd need to try and figure out if there was a good time for people. Whether some people might prefer a weekday evening thing, other people might prefer a weekend thing. So we'd need to hash that out, or maybe come up with a couple of things. Bruce, let's get in touch after we've caught our breath from vNARCON, and maybe we could post a when is good poll onto the Make It Take It group, and see if people want to try and pick a good time to get together. And we can see if we could make it work. All righty. Well, unless there's anything else, I guess I'm thinking we might want to shut it down here. Thanks everybody for coming. Hope you're enjoying vNARCON. Hope to see you on the flying field. Hope to stay in touch with you on the Make It Take It. Bruce, thanks for all the work you've been doing and helping out here. It's been huge to have a partner during the adventure.
Yeah, I'm just glad that it was my intent, to try to get something like to this degree, and I didn't find my round to it. So apparently you did, and but that the getting over, just if we can get people over that hump of installing it, then, it's pretty smooth sailing. Then, people can do it. But, unfortunately, the different platforms all have their own little different problems. And, even with the internet, grinding through it is tough sometimes because, you got out of date information. It's not always, up to date. You're looking at something old, and it just, it does take a while to figure out really what's going on.
Well, and of course, Tim Van Milligan's Manufacturers Forum was basically him singing, that was the song, the entire time was trying to support multiple platforms, and how he decided he didn't want to do that anymore. So I feel his pain.
Yeah, the one, and Arduino looks like that's where they're heading, with the 2.0 and eventually, web-based. The only real problem after that is you still, if you're just, well, even browsers have different standards, but the one thing that complicates it a little bit is to connect to the Arduino, you still need a driver, and you're still kind of platform dependent on that driver. So like one of the problems we run into Windows is I've tried installing on like Windows 8 and 7 machines, and I just can't get it to recognize the board. Trying to install different drivers that I found, I haven't had any luck. You pretty much need a Linux machine or a Windows 10 machine to get the board to be recognized.
Yeah, okay. It'll be interesting to see if, I'm surprised that they haven't tried to transition to some wireless thing, like some, Bluetooth thing for uploading code. These expressive people with their built-in RF protocols and stuff. It'll be interesting to see if they start doing that to try and get away from the serial driver issues. All right, folks. Bruce, great job. Thanks everybody for attending. I hope it was fun. Hope to stay in touch. Enjoy the rest of vNARCON. Bye-bye.
Bye.